Alright, today we're going to find the area of triangles with different given information. Depending on the given information determines which formula you use. If you get the base and the perpendicular height, it's 1/2 times base times height. That formula still lives, it's still around. But they're not going to be like that in this section. We're either going to be given side angle side, so if we have some triangle, let's say this is A, B, and C, and little a, little b, and little c. Suppose they give us sides A and B and angle C. So side angle side, the angle is between the two sides. If it's side angle, you'll have to do some law of sines to find the missing angle, and that probably gives you an angle side or angle side angle situation there. You probably want to go with that technique. So just so you know, if that happens, we don't have a side angle on here, so use law of sines first to find the answer or answers, and then find the area or areas. If it's and the formula is 1/2 AB sine of C. So half of the product of the two sides times the sine of the included angle. That's, in my opinion, the easiest formula to use. The second one is if you have angle side or angle side angle. The side is side A for the sake of this formula, and the angles are A, B, and C. So notice angle side, we're given two angles. So first of all, find the third angle, 180 minus the other two angles. You want to know all three angles on the side. It's A squared, sine of the two angles that aren't opposite the side, divided by 2 times the sine of the angle opposite the side. So if you're going to have all three angles, whichever side you know. Let's say I know side B, it'll be on top and B on bottom, that'll be A and C. If you know side C, C on top, C on bottom, that'll be A and B. If you know A on top, A on bottom, that'll be B and C. So again, just sine of the two angles that aren't opposite the side divided by 2 times the side opposite, the sine of the side opposite. And finally, the last one is sometimes referred to as Heron's formula. But if you have side, the reason it's called Heron's formula is there's a guy from Alexandria, Egypt, back in the good old BCs, like 10 BC or 1000 BC, I don't know, somewhere back in the day before they had calculators. He is the first guy to get credit for this formula. So, seems odd to me they knew what square roots were back then, but they didn't have calculators or anything, they could do square roots. But anyway, that guy came up with the formula. If you know all three sides, you first find half the perimeter. S stands for semi-perimeter, half the perimeter. And whatever the perimeter is divided by 2, and that number times that number minus each side, take the square root of the product and you get the area. Works every time. Pretty nifty little formula. So if you know all three sides, that's what you do. So if we look at example 3. Given angle A is 62 degrees, B is 12 meters, and C is 5.0 meters, find the area of triangle ABC. So looking at the triangle drawn, if it's not drawn for you, draw it. Same way we drew it before. ABC, side A is opposite side A, side B is opposite side B, and side C is opposite side C. We can see side angle side. Establish what type of information is given to you, and allow that information to establish how you're going to find the area. In this case, the area formula is 1/2 times this one side times the next side times the sine of the angle between. And then we just type our calculators. So 1/2 times 5 times 12 times sine of 62 degrees. And that comes out to 26.4884277.9. Better known as 26.49. Unit of length here is meters, so it'll be meters squared. And that's basically how to do all the problems today. You identify the information that allows you to use one of the formulas, apply the formula correctly, your calculator will calculate, hit equals, write the answer down.